Let's go through LeetCode 856 score princess. For this question, it gave us the string S, and S is a balanced princess. And let us count the score. It have the base case like this kind of princess, just this pair has score 1. And also you see that have this kind of two rules. One is that AB has got A plus B. That if A and B both are balanced, then we add the score together. And also if A is balanced and also there is a princess outside, the score will multiply by 2. Let's take a look at the example. This is the base case. And for this one, the inner side had score 1. So we have another score outside. So, so the score total will be 1 multiplied by 2. And for this one, we have score 1. And this one will have score 1. And we have the formula like AB, that is A plus B. So that will be 2, 1 plus 1, right? So in just by this kind of scenario, for example, we have this is 1 plus 1, right? And you will have another princess here, then we'll multiply 2, right? So first scenario is that first case is that for this kind of princess, what we think about is we can use some kind of stack. And every time we iterate those kind of charts of string S, right, character of string S, we look at whether it is a left princess. If it is a left princess, we just push that into a stack. And then we also look at if it is the right princess. What we are going to do is that we'll look at the previous element that whether it is number or not, right? If it is number, what are we going to do is that we are going to look at what's the things in the stack. If the number, then we are going to pop everything in the stack until we meet left princess. Now for this part, if it's number, we just sum them up, and for example, we have 1, 2, right? So we have sum then like 1 plus 2, and then until we have left princess, then we have this sum, just multiple by 2, and we pop all those things out and push the result again as a number into the stack. And in the end, when we iterate the stack, what left on the stack is just some kind of numbers, right? Then we sum them up. So this is the first approach to do in a stack way. Let's write code for this. We want to store number and princess into the stack, so we can store object in the as a type. And that type is that we can use string. Let's say for char C as char, right? So we'll say if this C equals right left princess, right? Then we just have stack of push. We push this one, right? This one into the stack. If it is right princess, we'll say int sum equals 1, right? And then we'll say while stack pick doesn't equal to left the princess, right? Then let's have this sum equal to 0, and we'll have sum equal pass equal to integer pass integer pass it stack top. And you know what we are going to do is that we need to pop the left princess again, right? Pop. So we know when we meet the right princess in the for the water let's say in the pick the stack, it can be a left princess or some kind of numbers, right? So we'll say the sum and so we'll say if the sum equals to 0, that means there is nothing here, right? Then that is the left princess. Then we're going to push 1 into the stack. Otherwise, we'll push the sum multiple by 2, right? So we are going to use that stack push. Which what? Sum. If we use sum still equal to 0, right? That means we are going to push 1, the string 1 into it. Otherwise, we're going to push level to multiple by some. Okay. And then in the end, we have int result equals 0, right? While this stack is not empty. and we'll have the result plot equal to integer percent right pop. Yeah. And in the end, we just return this result. Okay, so this is we're doing like a stack, and actually for this question we can also do the way like using recursive way, right? Recursion to do this question. To do the question like um, recursion is that we can have a DFS function which have a string as the input parameter, right? And we have a start index and end index. And what return, well, for this constraint, this start index and this end index, from this start index to this end index, what's the score? It is, right? So if we do recursion way, what we need is we'll return what? Return PFS, and we'll have 0 in the start as 0 and as um mm, mm, do this change this to cherry to get it better array with s to cherry, and that we just need to get the index every time, and we'll have in array dot s, right? And then we'll have n minus 1. So what we return will have private in the DFS function, and we'll have a cherry in start and right. So this DFS means in this kind of cherry, the index start to end in this kind of range, right? Include the start and what the score it has. So we'll say if end equals start plus 1, right? We can also have array start equals references and array equals references, right? We just return 1. So for this question, what we are going to do is that for every string start to end, we're trying to see whether it can be separate into two parts. For example, we find we know from S to E it is balanced. So we count, for example, the left and the right. Left count and the right count. And if we find a subarray from S to I, which have the left count equals right count, then we can divide this S to E from S and to E to two parts, S to I, and I to I plus to E, right? So we can have this kind of substring S to E to be GFS as or the array S to I plus DFS I plus 1 to E, right? So if we find we just iterate, if we find a balanced part, then we can DFS like this. If we from S to E, right, we didn't find the balance. And we know from S to E, it is a balanced string. So we can return 2 multiplied by DFS S plus 1, E minus 1, right? That means it cannot divide into several parts, which is balanced. That means for this kind of part itself, it is a balanced string. There is a big parentheses outside, so we can remove this kind of parentheses. So what we do is that we are trying to see whether we have count in the middle, which have left equal to right. If we have found this kind of part, then we can divide this kind of start end to start y and I plus 2e, right? Otherwise, we just remove the outside. So we can do, for example, int count equals 0, right count, right princess count equals to 0, right? And we're going to for int I equals start I smaller than n, right? Because we want to find from start to end in the middle whether we can find a balanced part. So if at the end, of course, it's already been balanced, so we don't need to check again. So I plus plus, right? So if array I equals left chart, we'll have left count. This. And otherwise we'll have else right plus plus, right? So let's say if this kind of left count equals to right count, then we'll return DFS array start to I plus DFS array I plus 1 to n, right? Otherwise, for this kind of balanced parentheses, we just move the outside parentheses that will return. That means when we iterate from the start to end, we didn't find in the middle. There are a subpart which is balanced. Then we'll just return multiple by two multiple by DFS array start plus 1 and minus 5. So this is the recursion way to do this. And for stack, right? Stack and recursion, the time complexity, because we are going to iterate the whole string. The time complexity will be O(n), right? Use a stack, the space complexity will also be O(n), right? Then the recursion way, the recursion function stack will also have space complexity. So it will also be like some kind of a coefficient number multiplied by n. And for this question, we can have some mathematical ways to do that. We know for when we count this string, for example, this. Okay, let's take this string as the example. We have this, right? This, right? So we'll find this number returns 10, right? So 10 is what? 10 is for this part, we'll see this inner parenthesis. It has a layer 1, 2, 3. And when we count this part, this when we count this, we'll see this is the third layer. And for the first layer, it has number 1, right? And the second layer, it has the number 2, and the third layer it has number 4. And when we have this one is this princess is still in the second layer. So we'll have so this one is still the second layer. So this part have the score 2. And this is also still the second layer, so it also have 2. Sorry, this is also the third layer, so this will have 4, right? So this is the second layer, this will be 2. So the result will be like this. But when we calculate, we'll have this 1 plus 1, right? And multiple by 2, and plus 2, right? And then multiple by 2, right? So actually, you'll see, this is when we calculate how we calculate. But the thing is that every time we find a right princess, and if the princess before this one is a left, then we know we need to calculate some kind of components. For example, this is 1, right? And we know this one is actually this equation equals 1 multiplied by 2 plus 1 multiplied by 2 and plus sorry, this is 1, right? Plus 1 multiplied by 2, right? And originally what we calculate is 1 plus 1 multiplied by 2 plus 1, then have parentheses multiplied by 2. So we know this it can separate into is equivalent to this. That means when every time we meet right parentheses and it's previous is a left parentheses, then we can calculate one of the component here. And how deep is this parentheses? We'll calculate how much is this. For example, this has level 3, right? Then level 3 is the 4, right? So for this component, we'll add 4. And also this princess, it also have level 3. You see, we can calculate when we have a left princess, we can calculate the level. And for every left princess, we'll have the level counted, and right princess will minus the level. And we have a left again, right? So this princess is also level 3. So this will also add 4 as well. And for this part, we remove another 2 right princes. So this one is just level 2, right? So we'll have plus 2 here. So the equation we write straightforward is pretty much like this 1 plus 1 multiplied by 2 plus 1 her princess multiplied by 2. This is equivalent as 1 multiplied by 2 by 2 plus 1 multiplied by 2 by 2 plus 1 plus 2. So in this way, we can just calculate when we iterate the string. We just calculate how many left princess and right princess. And also, if we see a right princess, we can calculate what's the level it is, right? So if it is level 1, right, for the whole string, it is just return 0, return 1, sorry. If it is level 2, right, then we'll return 2, right? And if it is level 3, we return 4, right? So it would have our equation into different parts. But to sum that up will be our result. So writing like this way, we can have int level equals 0, right? And for char 0 means that's to char, right? So that if we say equals left princess, we'll have a level plus, okay? And else, that means it is right princess. Else, we'll have its level minus, okay? And only when it's the previous character. Let's do this. For int I equals 0, I smaller than this char array, that's switch array, in this array length I plus. We have char 3 equals I. We'll say if it is right princess, right? But no, right princess, it cannot be the first one, right? So we know if array I minus 1 equals left princess, then we can add this to our sum, right? So we'll have sum into result equals to 0. And we'll have a result plus equal to 1 left level. Okay. So that means if it's there, just a 1, which is level 0, right? So this is level 1, right? Level 1. And when we're coming out, when we have this, this become level 0. then this one we just add 1 to our result. And if, for example, if we test level 1, 2, 3, okay, and when we're coming out the right one, right, and we know we meet a right princess, and on this one is the left princess, then we need to add the components. We know this one we need to when we're coming out the right, it become level 2, right? So that means we are going to have one shift left shift two digits. So we'll add 4 to the components. And in the end, what we need to do is that we just return the result. And doing like this way, the time complexity will also will be O(n), right? Because we iterate the string once. And the space complexity is constant.